let's begin taking a look at derivatives. So, what is a derivative? First of all, it's actually pretty simple. It's the rate of change. It is the slope. So if we have any graph, say this graph, our rate of change is the derivative, and we could take that from any 2 points. So if I wanted the rate of change, say, between these 2 points, I could find the slope of the line that connects them. Of course, that's really not anything that new. That's something that an algebra student could do. So it's a little bit more in-depth than that. Now, we're going to have two basic types. Now, this one on the left, the average, isn't really going to be the derivative, but it is how we're going to arrive at the thing that we want. So the average rate of change, we would have 2 points. This point here, say, would be our x1, our first point, and this here would be x2, and then we use our slope formula. Now, what is slope formula? M, which represents slope, equals change in y over change in x, which we could write y2 minus y1 over x2 minus x1. But this is where we're going to want to land at, an instantaneous rate of change. That is the rate of change at, say, a certain point. So if we take a look at this picture, and I'll just draw it again down here, exaggerate it a little bit. Say I wanted the rate of change right here at this point. Now I could take these 2 points and estimate it by connecting a line right there and finding the slope. And then basically, as I bring those 2 points closer and closer together, I'm going to get a better and better estimate for what that instantaneous rate of change is. So instantaneous rate of change is the rate of change at a point. And what we're used to is finding the rate of change, or an average rate of change, between 2 points. But we're going to use 2 points in order to get here to this instantaneous. So let's just kind of take a look at an example. So here's a graph, and I've asked to find the rate of change, the average rate of change, from any 2 points. So here's my interval, -6 to 4. So if I look, -6 is right here, and let's see the y value, 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9. So y is -9 right there. And at 4, so here's 4, 1, 2, 3, 4, 5, we have y equals -5. So our average rate of change is going to be change in y over change in x, which is going to be, I'm just going to go in the order of the points. It really doesn't matter as long as you're consistent. And -6 minus 4, so I'm going to get -4 over -10, which is 2/5. So on average, I'm going up 2 points and right 5. So let's just test that out. Up 2, right 5. 1, 2, 3, 4, 5. Up 2, right 5. 1, 2, 3, 4, 5. And yeah, we arrived at that point. Okay, so I'm going to do these others. So -4 to -1. So at -4, let's see, we are at -7. And at -1, we're at -3. So I'm just reading these points off this graph. So our slope is going to be, now it's change in y on top. So -7 minus -3, all over -4 minus -1, gives me -4 over -3, which is 4/3. So that means if I go up 4, right 3. 1, 2, 3, 4, right 3. 1, 2, 3, and yeah, I'm right there at that point. Okay, 1, 7. So at 1, y is -2, and at 7, y is, let's see, 1, 2, 3, 4, 5, 6, 7. Y is also -2. So let's just kind of think about that. That is if I were to connect those points, that is a flat line. So I would expect its rate of change to be 0. Let's see. So y equals, because the slope of that line would be 0. So our slope, change in y, that's -2 minus -2, all over 1 minus 7. So that's going to be 0 over -6, which is 0. So yeah, our rate of change is 0 because this is just a flat line. And finally, if we do this one, -8, that's going to be this point right here. So that is going to be y equals -7. And to -6, we already found that that's y equals -9. So our change in y is going to be -7 minus -9, all over -8 minus -6. So that's going to be 2 over 2, which is 1. So there we have our average rates of change. So let's move into what if we were looking for an instantaneous rate of change. Now, I have a graph right here. I've made it up, and we want to know the instantaneous rate of change at x equals 4.5. So at x equals 4.5, that would be this point right here. I want the instantaneous rate of change right here. So since I don't have the equation, I'm going to have to estimate this. And to estimate this, I'm just going to do this. So what if I connected that top point to this point? Okay. That would give me a rate of change right there. But it's not very good, right? If I were to say take another point, maybe one that's closer, maybe this point, I'd see that now we're getting a little bit better, aren't we? And what if I took this point as my first, and now we're getting, you see the lines it's very hard to distinguish them, and eventually I would get right here flat at this point the closer and closer I get to this. Now I'm not going to do all those different rate of change, this is just kind of to go over the concept. What if I wanted the rate of change at x equals 1? So x equals 1 is right here. So I could take this point. Okay. That's not very good, right? So I want to get it closer. And then maybe closer. And then maybe I would take this one right here, the closest that I have on my graph, and that would get me a pretty good estimate. But what I'm going to want, actually, is to get those points so close together. Like if I wanted this x equals 1, maybe I would take this point. And that's very, very close. And actually, I want this distance between those points to be so small that it approaches 0. And that should clue you in what we're going to do. We're actually going to take a limit here in order to do it. So, slope is change in y over change in x. And I'm going to use x plus h to be my second point. That's my second point. And x is going to be my first point. Well, then what is h? H is just a little more, right? It's just a little bit past the point. And in fact, I'm going to make that h go to 0. I want the distance between my 2 points for my slope to actually be 0. And that's going to be my limit. So here I've substituted in, so change in y. So that would be f of x minus, or f of x plus h minus f of x all over x plus h. This would be y, or x1, or x2, sorry. And this would be x1. And this would be y2. and this would be y1. And then I just simplified down here. That shouldn't be an f of x, that should just be an x right there. The x's cancel, leaving me with just h. So I'm going to take the limit as h approaches 0, and that's going to give the instantaneous rate of change at a certain point. So let's go ahead and do a couple of examples and see how this will work out. So the directions say find the instantaneous rate of change for each function at the given point. So here's my function, x squared, and I want it at 2. So the first thing I'm actually going to do is I'm going to say, well, what is the f of 2? And that's going to be 2 squared, so that's going to be 4. So this is my y. So now I'm going to set up this limit. I'm going to do the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so of course I can't evaluate this limit directly because if I put in the 0 right here, I'm going to have a problem. Now I'm not going to keep on writing this limit just so I have room, but technically you should. So, all right, I know f of 2 is 4. So this piece right here is a 4. So I'm going to put that in all over h. Okay, and I'm going to put x plus h into this function. So I'll do that right here. That would be this, and that will give me x squared plus 2xh plus h squared. Now I know what x is. X is 2, right? So if I put a 2 in here, that's going to be 4 plus 8h plus h squared. All right, so let's put all of that in here. All of this is replacing this piece right here. So that's going to be 4 plus 8h plus h squared. Okay, and I'm taking this limit as h approaches 0 of all of this. So the 4's cancel, right? So that leaves me with 8h plus h squared all over h, and I'm going to take that limit. Now notice, I could divide all of that by this h at the bottom. So that's going to give me the limit as h approaches 0 of cancels right there. So we have 8 plus cancels right there, h. Now h goes to 0, so I'll plug in the 0, and I get the limit is 8. So that's our answer. That's the instantaneous rate of change at 2. It's 8. Okay, now notice the h had to cancel. Okay, the h had to cancel. So let's take a look at example 2. We have a square root this time. So let's say 4. So the first thing I'm going to do is I'm going to find the f of 4. And that would be square root of 4, which is 2. Okay, so this is essentially my y. So I'm going to do the limit as h approaches 0 of f of x plus h minus f of x all over h, and I'm going to start substituting some things in. Now I know f of x, that's 2. I need to find f of x plus h. So I'm going to put that in, and that's going to be square root of x plus h. Now I know where x is going, right? X is at 4, so that's going to be square root of 4 plus h. So this one's going to be tricky to do, but we can do it. So we're going to have the limit as h approaches 0 of square root of 4 plus h minus 2, because f of x, I put in that 4, I got a 2, all over h. Now this one's not going to be as easy to figure out, but I can do it. I'm going to get rid of this guy right here so I have some room to do what we're doing. I'm going to actually reverse rationalize. So I'm going to multiply top and bottom by 4 plus h plus 2 all over 4 plus h plus 2. So I'm rationalizing the numerator, essentially. And I'm going to take the limit as h approaches 0. When I get that, I'm going to get 4 plus h, because that quantity is going to give me square root of 4 plus h squared, minus 4. And I'm actually not going to multiply out the denominator, because I'm hoping that the h is going to cancel anyway. And 4 minus 4 is 0. So that's going to give me h over h times square root 4 plus h plus 2, and the h is canceled. That's going to leave a 1 in the numerator. Now, h is going to 0, so if I put a 0 in here, I'm going to have square root of 4. So square root of 4 is 2. So I'm going to have 2 plus 2. So 1/4 is my average rated, or not my average rate of change, my instantaneous rate of change. Okay, last two examples, and hopefully you've caught on to how we are doing this. Instantaneous rate of change of 4. So the first thing I'm going to do is I'm going to find f of 4. That's going to be 4 squared minus 3 times 4, which is 16 minus 12, which is 4. So I'm going to find the limit as h approaches 0 of f of x plus h. H is just going to be that little bit past. And then we're going to have all over h. Okay, so now what we're going to do is we're going to put x plus h into this thing. So I'm actually going to do it over here, and we'll delete it. We'll have x plus h squared minus 3 times x plus h. And I'm going to start to simplify that. I'm going to get x squared plus 2xh plus h squared minus 3x minus 3h. And we're going to go ahead and simplify whatever we can. I don't think I can simplify anything there. So we got a big long thing right there. All right, so I'm going to substitute that in. I'm going to drop this limit just so I have some room. So I'm going to have x squared plus 2xh plus h squared minus 3x. Now, f of x was 4, so minus 4. All over h. So let's see here. What can we do? We substituted in, got this, our minus 4, multiplied this out, distributed that. Oh, I didn't copy it all over. That would help. What piece did I miss? I think I missed the minus 3h. So let's fix that really quick. Okay, so minus 3h minus 4. So let's see. We need to get this h to cancel somehow. So we know that x is 4 because that's what we wanted. So over here, this would be 16 plus 8h plus h squared minus 12 minus 3h. So I'm just going to simplify that down a little bit and get 4 plus 8h plus h squared minus 3h. So that's how I could simplify this down a little bit. And I also have this minus 4, but we'll get there in a second. So we have 4 plus 8h plus h squared minus 3h minus 4, and I'll deal with that in a second. The 4's will cancel, and we have 8h plus h squared minus 3h all over h. Now I'll put my limit back. I am taking the limit as h approaches 0. Now notice I could factor out an h and cancel. So I'm just going to cancel a bunch of h's, and I'm going to take the limit as h approaches 0 of 8 minus 3, and this would be over 1. So over 1, which is going to equal 5. So our instantaneous rate of change is 5. All right, so this one on the right is actually going to be pretty tricky. So let's see if we can figure it out. So we have a rational, and we're going to start it like we've been starting it. So I'm going to go ahead and find f of 6, and I'm going to put in a 6. So 3 over 6 plus 2, which is 3 over 8. Okay? And while I'm at it, I'm going to go ahead, and this is good practice, I'm going to find f of x plus h. I'm going to find out what that is, and that's going to be 3 over x plus h plus 2. Again, h is just going to be that little number. Now I know that x is going to 6 because I want it at 6. So that's 3 over 6 plus h plus 2, which is 3 over 8 plus h. And I'm going to go ahead and get rid of this piece right here just so I have some room. And I'll even erase this. Okay, so now what we're going to do is we're going to take the limit as x, or not x, as h approaches 0 of, all right, so it's this piece first, so 3 over 8 plus h minus 3/8 all over h. Okay, so, wow, I need to get this h to cancel. Well, why don't we go ahead and do this subtraction up here? So to do that, I'm going to need a common denominator. And my common denominator is going to be, and actually I'm just going to show all this combining, then I'll delete it. So it's going to be 3 over 8 plus h minus 3 over 8. Our common denominator is 8 plus h times 8. So this does not have an 8 in the denominator. It has the quantity 8 plus h, but it doesn't have just an 8. So that's going to be 3 times 8 is 24. Minus, this one doesn't have the 8 plus h, so I'm going to multiply by 8 plus h. And I'm going to go ahead and simplify. So 24 minus 3h all over 8 plus h times 8. And the 24's cancel, leaving me with negative 3h all over basically 64 plus 8h. Okay, so that's this numerator. Okay, and I'll go ahead and delete this portion down here, so that is out of the way. Okay, so we need to get that h to cancel. So I can actually get that pretty easily if I do this. If I multiply top and bottom by that. Now, what am I doing? I'm actually multiplying by 1, right? If this whole fraction would reduce to a 1. So at the denominator, the h's are going to cancel. Now that trick isn't always going to work, but in the case of rationals, it will. So the denominator is going to be a 1, so I don't need that anymore. And then if I take a look at my numerator, these h's will cancel. So that leaves me with negative 3 all over 64 plus 8h. But h is going to 0. So if I put in a 0 now, I'm going to get negative 3 over 64. And that is my average rate of change at 6. Hopefully I didn't mess up with that negative. I don't remember. I deleted all the work. But that gets the gist of it.